Hello, I'm Richard Patterson and welcome to another video presented by IPC Irwin. We're going to look at a few IPC Irwin products in this sequence, and we're teaching light and waves and ray optics. So I'm going to show you this 12 volt 24 watt incandescent lamp. This will draw around 2 amps, so this bench supply can lamp it. We'll switch it on. It's quite bright, so it's very useful for demonstration purposes to a large class. One safety issue is that it does get quite hot, so just be careful if the students are using it, you don't touch there. So to begin with, when we're demonstrating light and electromagnetic waves, we want to look at visible light, and this is a common feature of our lives, and talk about how the energy is spreading out in all directions from the filament there. Got electric energy store, and it's providing energy in the form of visible light around the bulb there, and it spreads out. So how do we try and understand that from a physics point of view? Well, if we switch the lamp off and replace it with the Raybox, this is the construction of the Raybox, and again there's a smaller incandescent lamp in there, again 12 volts, and if we connect that to our power supply, it again is spreading out visible light in all directions. But what we can do, because of its casing, is to separate it down to one streak or ray of light, which can be seen better when we have a piece of white paper there. So what we're going to do with the students is get them to investigate how this ray of light behaves, and then if that ray of light behaves in a certain manner, then we can say that all the thousands and thousands and thousands of rays of light that are coming out when we have a beam will behave in a similar way. So we're using the behavior of the ray to explain behavior of the beam. And we can take that to any light source, a star, the sun, a candle. All of them have got light streaming out, but for the students we're going to focus on one tiny streak of light, which we call a ray. So hence we call this piece of equipment the Raybox. Now this piece of metal has got 3 slits in, and we can get the light. There's 3 rays coming out there, and you can see they're spreading out or diverging. But for this demonstration to begin with, we're going to just use one ray there. So what I've got now is, if I replace that with this card, which has got a circle on it, and this is a bit of scaffolding for the students. It'd be normal just to give them a piece of plain paper and get them to use a sharp pencil and a ruler and a protractor to do this work. But I'm going to use this pre-printed protractor to demonstrate to you what's happening when we hit a plane or flat surface or a mirror. So we've got a little mirror there from an optics kit there. It's quite safe. It's acrylic with a reflective surface on it. And the first thing we're going to do is we're going to place that on the protractor, and we're going to get the ray to hit the mirror, and it's reflecting off, but it's going back the way it came. So we can just see one ray there. Now you might want to bring in the technical terms here. We call this line here, which is at right angles to the mirror, the normal. And the ray that's coming onto the mirror we call the incident ray, and the ray that reflects off it, the reflected ray. So we can rotate this around like so. And there we have a ray of light measuring from the normal line 15 degrees. And we call that angle the angle of incidence. And if we carefully align those, I hope you can see that the reflected ray is here now. It's not as bright, but it's still visible there, and it's going along the 15 degree line. So we've got an important property there. We can see that the angle that it hits the mirror is the same as the angle that it leaves the mirror. And we use these terms: angle of incidence between the normal and the ray, and angle of reflection between the normal and the reflected ray. And as I said, students can do this without this scaffolded printout. And if we try that for any combination of incident rays, we can go for 30 degrees there. Again, the reflected ray now reflects at 30 degrees to the normal line as measured there. So that's an important property of light. The Raybox is helping us do that by just reducing the beam of light to one single ray, like so. So what I'm going to do now is just show you a couple more of the accessories that we can use with the Raybox. And I'll remove that card and flip in some plain white paper, and I'll switch over the slit so we have 3 diverging rays there. So the second item from the kit is this piece of curved plastic. It's mirrored on both sides, and if we use it with the incident rays on this side, it's like going into a little cave, and we call that a concave mirror. And if we turn it around so that they're going onto the outer surface, we call that a convex mirror. And I hope you can see that the rays now are diverging from the curved surface. But if we rotate it round, the rays are converging and actually cross at this point here. You call that point the focus. All these can be demonstrated using these little accessories, and the students can do this themselves. So I'll take that away, and finally we'll just look at these acrylic blocks, which we call prisms. We'll change back to one single ray here, and if that ray is incident on this surface of the prism, doesn't go straight through, we can see it's displaced and it's coming out this side here. So what's happening here? Well, this is a phenomenon of refraction, and again, I'm sure if you look at the teaching notes on IRP Spark, you can see a full practical there on how to measure things about refraction. There's a law to look at, etc. And if we remove that prism and go back to 3 rays, a practical application, a very important practical application of refraction that we use if we've got an eyesight deficiency, is the lens. And there we have what we call a convex lens. The rays are going through, they're refracting, and they're brought to a focus here, and then they carry on. So this is a convex lens. Again, plenty of other practicals and measurements we can do with that. The last one I'm going to show you is the concave lens, where the rays enter it, they refract, but instead of converging with the concave lens, the rays diverge. So all this is done using power supply, IPCO in Raybox, slits, and a set of accessories, and that should cover all your optics that we normally encounter on a physics course. So thank you for listening to this video. Here's the QR code, and as ever, you can find full instructions, safety instructions, and using this from the IPCO in website, Institute of Physics Spark site for teaching notes, and if there's any relevant safety notes from CLIAPS, you'll find a link through this QR code as well.